All right, for the section 4.2, a lot of things we have already seen because we have seen all those functions. So, sometime this part of the lecture, what we are doing is we are trying to find the unit circle. Okay, now the unit circle means the radius of circle is 1. Okay, now you will think that we are still in the same boat. Still we are talking about the trigonometric functions, but before that we'll talk about a little bit about the unit circle. So unit circle with a central angle measuring the t radius, because remember we had a formula for measuring the arc. Remember that? We had a formula and which was r theta. Now in case of the unit circle, interesting thing is you don't have the r because the r is just 1 unit. So you just, 1 times theta is theta, and then you assume that this is your, you can replace the theta by t. So you just get the radian measure of the central angle is t because you are measuring that in t. Now in some cases when you are going to the reverse direction, your t is negative for sure. It's just like how we did yesterday. The length of the intercepted arc is t. This is also the radian measure of the central angle. Thus, in unit circle, remember all these discussions are true in case of the unit circle where the radius is 1. The radian measure of the central angle is equal to the length of the intercepted arc, and both are given by the same real number t. Okay, because your radian is, in fact, some cases the radian is the real number, because what do you get in the radian? Because when you let's say complete the whole cycle, you get 2 pi, right? That's a real number because the pi is 3.14. So 2 pi is 6.28. So here are the 6 trigonometric functions, and these functions, interestingly, these functions are applied to the unit circle. Now what happens, because of those unit circle application, some of the value is gone, because what happened is, let's say the sine t becomes, t is the angle here. So we are assuming that this is our right triangle because let's say this is the hypotenuse, this is the, let me draw it here. How you get the definitions of trigonometry. So how you can define the trigonometric functions in terms of the unit circle. So let's say this is the circle, and in the center something like this is going on. Let's say this is your t. So t is the angle here, this point. Now let me try to make a dotted line just to make sure that you understand what is going on. Okay. Now here, look at this carefully. Now the opposite side is not drawn in the original picture, but there is an opposite side. Now what you will get here, sine t, let's say sine theta, right? What is the formula for sine t? Is opposite by hypotenuse, right? Now what is your opposite here? Now they assume the opposite is y because of the function. Okay, because we are assuming that look at this is your y-axis, right? And this is your x-axis. So anything you are cutting here, that is basically your y. Okay, that is your y. Anything you are cutting, that is your y. So that's why the length is, or the opposite side is y, but the hypotenuse is 1 because this is a unit circle. Look at this hypotenuse. This is nothing but the radius, right? And we know the radius is 1. So that's how they come up with y. I just wanted to make sure that we understand how the sine t equals to y, how you can write that. So that's how the sine t, remember all these are the same functions, we have the same formula, but we are defining the functions in terms of the unit circle. Okay, in case of unit circle, one of the things that is different is the radius is 1. So radius will be always the hypotenuse. So the hypotenuse is gone because that is 1, or it's not gone, it will be always 1. And some of the cases the length will be compared to either x or y based on how the length is there. Now in case of, let's say, cos, what happened in the cos? Look at the cos t. I'm just trying to show you how you get that. Cos t. What is the formula for cos? Is adjacent over hypotenuse is 1. Now what is adjacent here? Now the adjacent is this, x. Because this is from x-axis, right?
That's why to generalize it, the write 1 over x by 1, which is x. So you can probably find all of those right now, just to make sure that you understand that how we come up with those in a different format. But I think they wanted to cover this part because they wanted to make sure that when you take some calculus class, you understand some of the math there, because in the calculus they use unit circle at some point. But I also try to discuss the 4.3 before the 4.2 because I wanted to make sure that we understand the trigonometric functions first, and then we see that how the trigonometric functions are applied in or defined in terms of the unit circle. Because if you just look at this first and then those later, it might be confusing. So let's see. Use the figure at the right to find the trigonometric functions at t. Now remember, the p is given. So what does it mean? Your x and y's are given. What is x here? Half, right? X is half. Look at the coordinate of the p. And what is y here? Square root 3 over 2, right? Now, from here, and you also know the hypotenuse, right? So from here, can you find all the, so let us write those x and y's here somewhere. So your x is half and y is square root 3 by 2. And let's go back to those 6 trigonometric functions defined in terms of unit circle. Now can you find all of this? I think we can do it extremely easily because all the trigonometric functions here are defined in terms of x and y. And since you know x and y, it's extremely simple. So everyone has those 6 functions. Just to let you know that the domain and range of these functions are all the real numbers. So all the real numbers are basically can be domain, and because you don't have any restriction for those.
The only thing that you want to make sure is the hypotenuse is 1, but x and y's can be anything. So any real number. Now, so here we are trying to solve the same problem in a different format. Exact values of trigonometric functions at t equals to pi by 4. Now, what is pi by 4? First of all, pi by 4 is 45 degree, right? Remember yesterday we converted the radian and degrees. So if you remember, the pi by 4, if you try to convert it to the degree, it will be 45 degree. And the question is still similar question. We are asking that what will be the exact value of trigonometric functions at t equals to pi by 4. Now use the figure at the right to find the trigonometric functions at t. Now we can still do that, and this is a similar problem just we did. Now the only thing which is new is look at the p here. What is p here? P is square root over 2, square root 2 over 2, square root over 2. So you know the x and y. So once you know x and y, you can find all the 6 functions, right? And this happens only when the t is 45 degree. So whenever t is 45 degree, that is going to be the ratio. So, and this is another example, but here this is negative because what it means is because this angle is equal to this angle. So basically, if you go to the negative side, and if you extend this blue line, you will get a negative 45 degree. Okay. So these are again trigonometric functions and 45 degree, which is extremely similar to what we have found in section 4.3. In the section 4.3, we know that all the angles, all the functions at 45 degree. For an example, what is sine 45? What is cos 45? What is tan 45? We know all of those, and we are just writing all of those, and the only difference is the angle is written in radian except the degree. So there is nothing new information. It's the same thing, but and also this is an interesting slide just to make sure that we understand that which of these 6 functions, because we have 6 trigonometric functions, and out of 6, which of these functions are even and which of the functions are odd. Interestingly, only the cos and sec, those functions are even functions, because remember the even functions. What is the property of the even function? Let me remind you the definition of the even and odd functions when we discuss. So in case of every even function, your f of minus x is going to be f of x. Okay. Now, as you can see from here, only the cos and sec, they follow those 2 properties. Now, what does it mean that cos minus t equals to cos t? Remember, t is nothing but the theta here for us. Okay. Now, this means that let's say you take cos minus 45 degree. This is exactly equal to cos 45 degree. Because the angle can be negative, right? I'm saying when you are moving to the reverse, I'm saying the clockwise, your angle will be negative. And even if you can plug all of those in the calculator, if you just try to find the cos minus 45 and cos 45, both of the answer will be half. So that means cos, in case of cos, f of minus x equal to f of x. Similarly, in case of sec, that is also true. So these 2 functions are odd functions. I'm sorry, the even functions. And the odd functions, if you try to recall, what is the odd function? This was the odd functions that f of minus x equals to minus f of x. So all other 4 functions, sine, cos, sine, tan, cosec, and cot, those are odd functions because their values are same, but their sign get changed when the angle is negative. So what it means that when you let's say this is 1 square root 2, and sine minus 45 has the same value, but the
Sign is different. This is true for all the thetas. Doesn't matter it's 45 or 60 or 30 or 90 or whatever. It's not true about 90 because 90 is always negative, 0, but it's true for everything else. Similar properties are true for the tan, cosec, and cot. So, can you find the cot minus pi by 4 and sec minus pi by 4? Now, first of all, the pi by 4 is 45 dB. Now, in case of cot, minus 45 will be what? Cot is an odd function. So cot minus 45 equals to minus cot 45, right? It will be equal to, so the cot minus pi by 4 is going to be minus cot pi by 4. But in case of sec, minus pi by 4 is nothing but sec pi by 4, because this is an even function. Remember, you can always find all these values using the calculator, but we just wanted to make sure that we understand what we are doing and why, in case of cos and sec. One of the reasons, let me tell you some little bit more about that why this is only true about the cos and sec. Have you ever heard that 4 quadrants have different values for different functions? Okay, let me show you here, then probably you'll understand it a little bit better. So, before I go there, these are some identities that hold also between those. Remember, I think we already discussed about those identities. Remember, I said that cosec is nothing but reciprocal of sine, tangent and cot are the reciprocals to each other, and sec and cot are the reciprocal of each other. So look at the first reciprocal identities. They are the same, same message, because sine and cosec, they are reciprocal. Cos and sec, they are reciprocal to each other. Tangent and cot, they are reciprocal to each other. And we already applied this, but the quotient identities for tangent, sine over cos. For cot, that's the reverse one, because the sine and cot itself, they are reciprocal. So it's just the ratio is flipped. And Pythagorean identities, I think I'm not sure whether we know this, but according to the Pythagorean identities, for any theta, sine square plus cos square is always equal to 1. And 1 plus tan square equals to sec, and 1 plus cot square equals to cosec square. So these identities are extremely useful in calculus. There are plenty of things that you will not be able to even start with if you don't know these identities. Okay. So at this point, you can assume this as a formula, but at the same time, we also want to make sure that we understand a little bit about how those formulas come into the picture, why they are true, or why they are valid. So, given the sine and cos, find the value of each of the 4 remaining trigonometric functions. It's an interesting question, because at this point, we are not only talking about the right triangle, we are just doing it a little bit different way. We are just considering all these trigonometric functions as regular functions, and we are looking at their identities, and then based on those different kind of identities, we are just trying to see that can we find other functions based on given some, or like here 2 functions. So what are given? We are given sine and we are given cos. Remember, in some cases you might have multiple options. You might have multiple ways of getting your answer. In those cases, you can choose your best option, or which one you like. It's up to you.
So this is the sine and this is the cos, which is so let's say this is given. So let's go back to those identities so that you can see what we are doing. Now let's say you want to find, you have sine and cos, so you want to find tan first. So maybe you can apply. It should not be a problem here. So writing the formula, you can solve it and see what you get.
I think you will get square root of 5 over 2 square root of 5. It will be half.
That's the tan. Let's see, I can add one more line here so that you know what we are doing. So that's how we get the tan. You can get the chord in the reverse way. So maybe chord T it will be 2, right? It's up to you. Probably you can instead of doing this, you can probably use this identity, which will be better, maybe 1 over tangent. So 1 over half, which is 2. Let's see what else. We have to find sec and cosec. So to find the sec, best will be 1 by cos t, which is 1 by to find the cosec t, one by sine, which is 1 by that's how we can get the other 4. Remember, you might have some other options too, because we haven't used any identities from the Pythagorean. You can also use the Pythagorean and get some of the answer, but I thought probably the other identities will give you the answer quickly, because in the case of Pythagorean you have to square it, square root it, so maybe the other identities are a little bit easier. During the test, you don't have to memorize all of these, you will have access to all of those, but you have to know how to use it or which one you need. But these, if you take calculus at some point, you will see there is a huge application of all these identities in calculus. Any question here? Okay, so all these are pretty much the similar question. We are given 2 functions and we'll be using the other identities to find those. So, okay, here given that the cos is these, and the t means what? The theta, right? The theta is from 0 to 90 degree. Find the value of sine t using trigonometric identity. Okay. Do you know why they wrote this? Why they gave you this information? Because one of the reasons they gave you this information, because when you are trying to find the sine, okay, and this is 90 degree, there is a chance of getting the function undefined when it is 90. Okay, because in case of cos, what happens is the value of cos is 0 at 90. Okay. That's why they just want to make sure that you don't use any formula where you might get into a trouble. Because theoretically, you can always divide x by y, that's fine. But theoretically, whichever you have in the denominator position, that cannot be 0. So still, you probably will be able to get that. So it's the same kind of question. So let's see how much time we are left with. Okay, we can probably go ahead. So we are here trying to define the periodic functions. So the periodic functions are again all these functions like the sine and cosine and all these trigonometric functions. They are basically periodic. So that's why these are the good functions where you can talk about the periodic functions. The periodic functions are the functions where there exists a positive number such that that for all number t plus p equals to f of t, because that means that for all t in the domain of t of f. So it means something like this. For an example, let's say if you look at the values of the sign, what you will feel is that all the values of the sign are repetitive. They will be coming back and forth, because doesn't matter what degree you have for sine, all the values of the sine will be something between 0 and 1. Doesn't matter what degree it is. Because for an example, if you start from sine 0 and go all the way to sine 90, it will be 1 and it will start decreasing. So those kind of functions, because all the values of the function are again coming back and
at a constant period, after a constant period. Because for an example, let's say if you try to draw or plot the graph of the sine, it will be like this. So it will be always like this. What does it mean? It means that the values are getting repeated. Now, for an example, let's say if you think this is your angles, let's say this is the angle 0, okay, and this is 90 degree. So this is like 180. This is 360. This is 270. Now what happens? From 0 to 90, at the 90 it gets high, which is 1. After 90, it again gets decreasing, okay, and then it gets decreased all the way to -1. I'm sorry, it's basically fluctuating between 1 and -1. So you see all the values are repeated, because you have 1 here. Again, after 360, this becomes what? 360 plus 90, which is 450. When you have 450, it becomes 1 again. So all the values are repeated periodically, and the period is basically pretty much constant. After a fixed period, you will always see the same value again and again. And that's why it's written like this, that that t plus p is always equal to t. So basically, you are adding a period with the t, and after that, you will again see the same value, because f of x will be same again. You see what I'm saying? Because the functions has the same value again and again and again. Okay, now first looking at that function, if you do the horizontal test, what you will come up with? Is this a one-to-one function? No, right? Because you can draw plenty of horizontal lines which will intersect at more than one point, right? So this is not a one-to-one function. So what do you know from there? Technically, there is no inverse function for sine. All right. So these periodic properties hold for sine and cosine both, because they have the. So if you look at this, that after 2 pi, they have the same value repeated. What do you mean by 2 pi? 360 degree. After 360 degree, look at their graph. Here, this is 0, right? I'm saying the value of the sine is 0. Here, this is also 0, just after 360. Here, this is 0 again. This is 720. After every 360, the value will be repeated. Now here, look at this. This is 1. After 360, again 1. After 360, there will be 1 again. So after every 360 degree, the value is repeated. Similar is true for cos as well. After 360 degree, because the cos has the same kind of graph, the only difference is this. Let me draw the cos. Only difference is this. If you draw the cos, it will be like this. So basically, this is 1, this is 0, this is 1, this is 0, but it has the same sinusoidal wave, so which is again the periodic function. Oops. So that's why they are repeated after, and that's why it's saying that for every periodic function,
there is a point when the values get repeated. And same is true for tangent and chord, but look at that. What is the difference? For the tangent and chord, the values get repeated after 108 degree, not 360. But still that is periodic. You are getting the same value again and again. So in general, to make it more generic, okay, we write the formula like this, because instead of that we just write n. N means n can be any positive integer. I'm sorry, not positive, any integer. Okay, if you plug here 4, it will be what? 8 pi. Still those two will be same. Okay, look at the difference. It's 2 pi n, and for tangent, that's just. It's also true for chord. It's just n, because there is no 2, because the values are repeated after every 180. But we don't have to memorize these formulas, and we don't have. The only thing that is, we just want to make sure that we understand the periodic functions. That why they are periodic, because they are valuable. There is no sign value which is larger than 1, which is less than 1. I'm sorry, larger than 1, less than negative 1.
Everything will be fluctuating between 1 to negative 1. Okay, so they have some specific range, because that's why that's repeated every time. Now, find the value of each trigonometric function. I think we can do this just in a lot of different ways. At this point, you can just convert it into a degree and then use the calculator. That's one way, straightforward. Or you can think it as a periodic function. Okay, then you can find the periodicity. You can write this as this, that t plus something. That's where you will understand this repetition. Now, this part here, check whether you can do it. I'm sure that you will be for sure, because a couple of slides here we added this slide so that you will do the same problems in the calculator, and also this is the last problem we have. Find the exact value of the trigonometric functions without using the calculator. Now how you can do that? Do not use the calculator. How you can do that? One option is using the periodicity. Okay, using the periodicity, and also another option is use this. Use this chart, because if you use this chart, you will know that what's going on in different points, because how the values are changing. Because we are just trying to show you that. Because doesn't matter how many degrees you are going on, still you are here. Let's say you have 450 degree. What do? Start from here, go all the way up to here is 360, then go another 90, that's 450. Okay, so every time you will be at some point, and you will know the values of those coordinates, and based on that, you will know what will be the chord and sine and those. So we'll probably start from here in the next class. Okay, so we just have 2 slides left, but we'll just talk about these 2 slides, and we'll jump into section 4.4. But before you leave, let me